Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. And right now we're in section 213. In the previous two little subsections, we talked about on power sets, talked about preserving merges on power sets. So if we merge different subsets together, what kind of prop structure can we preserve? We talked about preserving a post set structure, partial order structure, and also the existence of these arrows, which really any merge would do. We're going to now talk about merges, or kind of lead up to that. Merges need to also preserve other structure if we want this to really adequately describe logic and power sets to model how we think about logic and logic operations. So what we'll need to discuss merges or functions on a power set um, that surjective functions that preserve certain more structure, namely operations, the operations of union and intersection. So union and intersection. And this section discusses union and intersection in another way of looking at it or thinking about it, which will help us understand these merges a little better. So let's take a look here at an example. Let's suppose we have a set here, A, B, C, D, E, F. Okay, suppose that's S. Now, let's take a subset of S, so A, C, F. We can actually represent the subsets of S with code, binary strings of zeros and ones. And here's a little illustration how. See how this subset of S has A, C, and F? So if we list out all the letters in some order here, and we have to fix that order for this set, so A, B, C, D, E, F, and then anytime that we're choosing to include that letter in the set A or subset A, then we'll put a 1. And if we don't choose it, we put a 0. 1, 0, 0, 1. So we have a code 1, 0, 1, 0, 0, 1. And what does this code represent? This code represents a subset of S. So we're going to be looking at thinking of subsets as binary strings of ones and zeros. So if a set has 1, 2, 3, 4, 5, 6, so 6 elements, then the strings will be 6 long. And we can get all the different elements of the power set or all the different subsets just by looking at different strings of zeros and ones. So for instance, you could take a set A and a set B. Those are two different subsets of S, but now let's think about how we can apply these operations of intersection and union. Okay, let's do an intersection. So let's take this subset, and let's intersect. There's different ways we could think about intersection now with these codes. So here, let's take A and focus on the positions in the code that have ones. So you see we have a 1 here, here, and here. Remember, intersection is kind of like what's the same in each, right? Okay. Well, so what is in each, really, right? Well, if it's what is in each, then for sure, if you just pick one of your subsets, like A, say the first one, whatever, however order you put it in, it's going to be, the intersection is going to be within those ones, right? Because it has to be in A, and it also has to be in B, so we could just start with that. So we can circle those ones. So now we're just going to focus. Okay, now we're going to look at these same positions in the code for B. So we look at the same positions in the code for B, right? These are the options that we have for the intersection. And notice that we just choose So out of those positions, only two of them have ones, and those are in particular the represent the intersection. In fact, in order to get this, here's a little diagram. We take B as is right here, and then we're going to ignore anything outside of these circles, because if it's outside of those circles, then that means it's not going to be an A, right? Okay, so we ignore it, cross it out, zeros, and then then we got it, okay? And that's it. That's the code. This is the code for the subset of A intersect B. So kind of a simple thing is you find the circles that represent A, you superimpose them on B, and then you cross out anything that's not in those circles, and then you have the code for A intersect B. So it's an ignoring operation. We ignore things that are outside of A when we're looking at B. So we're looking at B with new lenses. We're just kind of ignoring certain positions in the code. And so that's one way of looking at intersection. Okay. Okay, here's another example. Let's look at the subset B again, only this time as the first subset in this intersection. So let's suppose we take this set B, and let's take another one, C, okay? All right. Now, in particular, that means, well, this example is nice because you see kind of the way that it's ordered, the code is ordered, has the ones up front. And so you can see kind of clearly what's happening. Anything on this side of the line in the code, you're always going to ignore whenever you're looking at another set. So if you're putting a C and you're going to be intersecting with B, then that just means that you're going to be ignoring anything after that position. And then, just calling it zeros. And then that's how you're going to get your intersection, which would be right here. Just take the first part of C and everything else will be zeros. All right. Now, union is the same type of idea. It is also kind of like an ignoring operation in some sense. Let's again take this subset B right here as our first guy, and we're going to union onto something else and think about what's going to be happening. So everything that is in B we want to keep, and we're going to just assume it's ones. Now notice when we were ignoring before with intersection, anything we ignored was kind of like zeros. Well, here, anything we're ignoring or taking for granted, you could say will be one. So that's kind of the only real difference, but it's an ignoring idea. Okay, so here we're going to take for granted that the first part of the code will always be ones whenever we union, and then we'll just tack on whatever is the last part of the code and then in the other one. So part C, or in C is C here in the subset C. And so we're taking so here, we take the code for C, and then the first part we're just going to ignore or kind of take for granted and just assume that it's going to be ones, even though it's not ones, but we're going to change it to ones, and the rest will just leave. 0, 1, 1, and then the rest are just ones. And that's one way of getting a union. Hence, union is a lot like an ignoring operation. So that concludes this little subsection of 2, 1, 3. Thank you for watching.